Hi, I'm Jacqueline, and this is my chemistry connections to raw sewage spills. Solubility. Solubility is defined as the maximum amount of a substance that will dissolve in a given amount of solvent at a specific temperature. Sugar cubes added to a cup of coffee are a simple example of this. The sugar can dissolve in the hot coffee, but after a while of adding a little bit more, will begin to settle at the bottom of the cup. The property which helps sugar molecules to dissolve is known as solubility. In this case, the sugar is the solute and the coffee is the solvent. A great factor of sewage is the nauseating smell that it is known for. Sewer odor comes from the breakdown of human waste and includes harmful gases like hydrogen sulfide, H2S, and ammonia, or NH3. Doses of these gases don't do much harm, but chronic exposure can be toxic, which is why the spillage of wastewater is a crucial problem today. Connecting to solubility, the solubility of ammonia gas in water is about 90 grams per 100 milliliters at 0 Celsius. This high solubility of ammonia is due to the presence of lone pairs at the nitrogen. It is attracted to hydrogen in the water molecule hydrogen bonds. The presence of hydrogen bonding between two molecules means that the molecules are polar. Contrasting to this, the low solubility of H2S is what causes the smell of the wastewater. So, as mentioned, the hydrogen sulfide has a low solubility in the wastewater, which causes it to be released into the air and surrounding community and causes the bad smell. Introduction to bonds. Chemical bonds are a lasting attraction between atoms, ions, or molecules that enables the formation of compounds. Ionic bonds are a link formed by the attraction of oppositely charged ions in a chemical compound. It results in the transfer of electrons from a metal to a nonmetal in order to obtain a full valence electron shell for both atoms. Covalent bonds are a link that occurs between two nonmetals or a nonmetal and a metalloid. They can be polar or nonpolar. Metallic bonds are created when the charge is distributed through a greater space as juxtaposed to the size of individual atoms in solids. In metallic bonding, the outer shells of adjacent atoms overlap, and the outer shell electrons are free to move through the lattice. Pipes. A great part in spills are corroded transportation pipes. This can be through oxidation and specifically by hydrogen sulfide, as previously mentioned. The steel displays metallic bonding and is primarily an alloy of carbon and iron with a small percentage of other metals. Bonds connection through H2S toxicity to humans. The high toxicity associated with hydrogen sulfide is due to its ability to bind to iron centers in mitochondrial cytochrome enzymes, which effectively stops cellular respiration and deprives essential organs of energy. Although humans do possess enzymes in the liver that oxidize hydrogen sulfide to sulfate, high concentrations of hydrogen sulfide will overwhelm human hydrogen sulfide oxidative enzymes. And this is why it is important to reduce the spills, as we can see what the effects are. Introduction to compounds. A compound is a substance that results from a combination of two or more chemical elements, where the atoms of the different elements are held together by chemical bonds. Water is an example of a chemical compound. It consists of hydrogen and oxygen in the ratio of 2 hydrogen atoms for every oxygen atom, resulting in H2O molecules. Sodium chloride is another chemical compound formed from sodium, Na, and chlorine, Cl, in a 1:1 ratio. The main classes of organic compounds present in the effluent or wastewater are saccharides, amino acids, fatty acids, hydroxyacids, aromatic compounds, and steroids. Commonly detected compounds found in debris buildup included antimicrobial disinfectants, antibiotics, musk fragrances, antihistamines, and anti-epileptic drugs. So those were basically what were found in debris buildup and maybe have been or had been flushed but weren't supposed to be. But the focus is on the cleanup chemicals that are used and the compounds that are in those. So many wastewater facilities that experience sulfide problems generally use aeration chemical oxidizers such as hydrogen peroxide and/or odor masking agents like essential oils, but these only mask the underlying problem and do not actually remove the sulfur and sulfide molecules from the system, which further is causing problems as the sulfur is still affecting, but it's being masked by the essential oils.